Now in this lecture, we are going to look at how the operations that we discussed in our previous lecture works in case of circular queue. Now we have mentioned that in case of linear queue, we have problem of empty cells when we are dequeuing the elements from the queue. But in this case, by using circular queue, we are going to solve that problem of empty cells in this case. Now the first operation is creating a queue. Basically, creating circular queue is same as the creating linear queue in case of array, because here we are just initializing the queue class with fixed size. So if we create an instance of queue class with the parameter of 6, it's going to create 6 contiguous cells in the memory. So it's going to create an empty array in the memory. Now in this case, as we said before, this is because it will take O(n) space complexity, because from upfront we are allocating 6 contiguous cells in the memory. Now this is the same as with the linear queue. So as we said in the linear queue, when we are creating an instance of queue class over here, we are going to set the beginning and top of the queue to -1. Now with this, when we see that beginning of queue is -1, we can identify that this queue is empty in this case. Now after creating a queue, the next operation that we are going to perform is inserting elements to this queue over here. So insertion in case of queue is enqueue method, so we are going to look at how enqueue method works in circular queue. Now in this case, when we initially inserting elements in circular queue, it is same as we did in the linear queue. So here we are enqueuing, for example, 5 to this queue over here. First we are going to insert the element at the index of 0. Then we are going to set the beginning of queue to 0 and top of queue to 0, because in this case we have only one element in our queue. So beginning of and end of queue is located at this 0 index over here. Now if I enqueue one more element over here, we are going to increase the top of queue to 1, and the beginning of queue will stay at the 0 index in this case, because 5 is the first element in this case, and the 6 is the second element, which is located at the index of 1. Now if I enqueue one more element, it's going to insert it after the 6, which is at the index of 2, and the top of queue will be index of 2 over here. So the top of queue will point to index of 2 over here. Now in this case, as you can see, enqueue operation in case of circular queue is similar to enqueue operation as we did in linear queue. So what is the difference over here? So as I mentioned before, here the difference make when we have empty cells that we have used before. So in this case, enqueue method works differently. Now if we continue like this, enqueue more elements to this queue over here is going to be full. Then after that, we can dequeue elements from that queue and enqueue one more time to see that how this is using the empty cells that we had before. Now in this case, let's say after enqueuing all elements over here, our queue becomes like this. So the beginning of queue at the index of 0 and the end of queue is located at the index of 5 over here. So all cells are occupied in this case. Now if I call dequeue method, it's obvious that it's going to remove element from the beginning of queue. Now when it's removing the element, it's going to return 5, and 5 will be removed from the queue over here, and beginning of queue will be at the index of 1 in this case. Now in this case, the 0th index cells become empty, so we can reuse this when we are enqueuing element over here. Now if I call the queue method one more time, in this case it's going to return the first element. The first element is 6, which is located at the index of 1. Then it's going to remove this element from this array over here. Then the beginning of queue will point to this second index over here. Now as you remember, in case of linear queue, when we had such situation, and if we want to insert a new element, it was checking that if the top of the queue is points to the length -1, in this case top of the queue is 5 and length is 6 and -1 is equal to 5, so this means that it was returning that the array is full. But in case of circular queue, if we want to enqueue element over here, it's going to insert at 0th index over here. So if I call enqueue method in this case, for example, if I'm enqueuing 1 over here, it's going to insert to this 0 cell over here. Now you might be interested that how we can identify that this is the first element in our queue or the last element. So in this case, we have to update the top of queue to 0 index. So top of queue will point to this over here. Now based on top of queue, we can easily identify that if this is the element is the first element in our queue or the last element. So with this, every time when we have empty cell over here, we can easily identify it from here and reuse it in the future. So as you can see, in this case, we will not have any empty cells in this case. So every time when we have empty cell, it means that our queue is not full. So this empty cell can be used for future elements that we want to insert to this queue over here. So with this, our dequeue method will take a one-time complexity, because in this case, we are not shifting the places of elements. We are just using empty cells that are available. Now let's continue to the next method. The next method is pick method. Now in case of circular queue, pick method works same as the linear queue. So here, based on the beginning of queue index, we are returning the element from this array over here. Now the beginning of queue is 1, so the element that is located at the index of 1 is 6, so it's going to return 6. So it doesn't matter how many times we run, in this case, pick method is going to return 6, because 6 is the first element in this queue over here. Now if we run the queue method and 6 is removed from this queue over here, and run pick method is going to return 7 in this case, because 7 is the second element in this case. So if we remove the first element, so second element will become first element, so that's why it's going to return 7 over here. Now let's continue to the next method. So the next method is isFull method. So isFull method is working differently in case of circular queue, because as you remember, in case of linear queue, we were just checking the top of queue with the length of array. So if the top of queue is equal to length of array minus 1, in this case we're returning that, saying that this queue is full, but in this case it's working differently. Now here we have several conditions. So the first condition is, in this case, if the top of queue points to the last element in this array over here, and the beginning of queue is different than the 0 index, in this case, it means that our array is not full because we have a cell available over here. Now, in which cases our queue might be full. So in this case, if the beginning of queue is pointing the 0th index and the top of queue points to the last index, it means that it is full. So in this case, it's going to return true, that this queue is full over here. Now, another condition might be like this. If we add 1 to the index of top over here, and we get the index of beginning of the queue, in this case it means that it is full. Now in this case, if we run isFull method for this queue over here, it's going to return true. Now the next method is empty method. Now as we mentioned before, when our queue is empty, the beginning of queue will be -1. So in this case, based on the beginning of queue, we can identify that if this queue is empty or not. Now here you can see that beginning of queue is not -1, which is 1. Now in this case, it's going to return false. So this means that our queue is not empty. Now finally, the last method is delete method. Now we have explained before that in case of linear queue, delete method is responsible for deleting a queue from the memory. Now here it's the same. When we call delete method for this new queue over here, it's going to delete this array and these references from the memory. So when we run it, it's going to delete them from the memory. Now with this, we have come to the end of this lecture. So in this lecture, I have shown you how the queue operation works in case of circular queue using array. Now in the next lecture, we are going to implement these operations one by one in practice. So see you in the next lecture.